Hi, so this short presentation is about the Ungoogable exam. So I think it's clear that online multiple choice question examinations, which transition to an online setting over the COVID pandemic, are here to stay. So how do we make those exams fit for purpose and make sure that they are ungoogable? So first of all, what do we mean by ungoogable? So we really mean that making sure that the students cannot in one or only a few clicks find the answer to the question easily on the internet, or an equal concern in only a few words express the answer to a question with a group of peers via a social chat platform. So in this short presentation, we're just going to go through a few ideas about how you can do that with existing questions. I want to say before we do that, though, that this presentation does in no way circumnavigate two other very important considerations when designing any MCQ test, whether that's one that's going to be delivered remotely online or in a closed book environment. And that's the general design and scoring of the tests, the weighting of the questions, the role of negative marking, and the actual pedagogic design of the questions themselves, which question choice you're going to be using, the alignment to learning outcomes, the number of options that you include within those, and some of the other pitfalls that sometimes occur in MCQ test design. And my colleagues in technology enhanced learning, who can be contacted at tel@derby.ac.uk, run training in both these aspects. And before we start going through question types, I just want to add a thought that may need to address at the end of the presentation, is that if none of these solutions work for you, is the MCQ exam right for measuring the learning outcome in the new environment that you exist? And instead of trying to adapt the MCQ, do we need to consider a new form of coursework altogether? Okay, so the first example of a way to make an ungoogable question. And when I say ungoogable, of course, everything with time and patience probably can be found on the internet, but it's taking that one click, quick clickiness away from the answer. Okay, so the first idea is called Google for them. So this idea of question type acknowledges that information is available on the internet, and instead of effectively trying to beat the internet by making something they can't search for, using the information that's on the internet as the basis of the question itself. And there's really kind of two frameworks by which this could work. In the first, you have the students, with the help of a prompt, which will be your question, look up information on the internet. So you're actually telling them to go onto the internet as part of the question to look for something or look for things. Of course, we all know that looking up things, typing keywords into Google is quick and easy, but understanding what you get back and the quality of what you get back is actually a real skill. And that could be the nature of how you frame the question. So getting them to interpret what they find and then report back on it in some way. Of course, instead of getting them to do the Googling, if you don't want to encourage them to go onto the internet, acknowledging that some may, is that you do it. So you search the internet for something and you use those internet sources as the prompts themselves. And then you get the students to process that information that you found on the internet and then once again report back. So where I've used the word understand there, that's the word that I'm using to represent the learning outcome, which of course can be a different learning outcome as appropriate. So I think I'd probably get useful to look at an example. So here's an example of a Google for them type question. So in the blue, you can see what I would consider a current typical MCQ question. Which of the following is the correct definition of, a thing? And obviously with the internet, you can very quickly work out which one of those is the correct answer. So here's two alternatives about how that could be done using the two different frameworks from before. So using the student prompt, you could ask them to, first of all, type below an appropriate definition for thing. So you're asking them to go effectively look for definitions of things on the internet and then put their own answer in the box. So how do you know that they won't just cut and paste the first one that they choose? Well, you could have parameters or conditions in your marking scheme against the key things you know that they need to interpret. Perhaps using appropriate definitions, state the fundamental difference between a thing and another thing. So instead of the straightforward just searching for one thing, you're asking them to look for two things on the internet. You're looking for A and B, and then asking them to explain the differences between A and B. So yes, they've got to find the information, which may be a quick thing for them to do, but then they've got to understand the differences between those, and that's the thing that you're going to ask them to report in the answer to the question. Of course, the other way round could be with a star styling, is that you could, using the two definitions below, state the fundamental differences between thing and another thing. So you find two definitions yourselves, which you can obviously vet in terms of quality or what information is presented. But then you're asking them to process that information and make a judgment about differences. So first of all, two things. Where I've used the word differences here and indeed the word definition, they're just illustrative. They could all be replaced by a different word depending on your question type. The second thing you may be thinking is, well, how do I mark that? Can I turn this into, an MCQ type answer, or am I moving towards a more open text type box answer? So in the way that I worded the examples, we're probably moving towards the latter example of open text boxes, but we'll address that later on in the presentation. Another good way to create an ungoogleable exam question or a more challenging exam is to create question variation within the question itself. So let's take this example question, which would be typical of an MCQ. If the value of x is 17.6 and the beta constant is 9.1, what is the thing? So here you're probably asking the students to apply a formula or equation or something in order to answer a question. So how can you increase the robustness of this question? Well, you could do two things. You could create a pool of questions with different values. So you basically duplicate the question. Make 3, 4, 5 different variations of the same question. But in each one, you change the value of x and the value of the beta constant. That means that, 1 in 5 students would have a different question to each other. Yes, they still need the same basic formula to interpret or understand it, but their answers will be different. Makes it a bit more challenging to share answers. The other way to do this is just create a single question. I'll show you how in a minute, with x and beta random created within a range by the Blackboard tests. So each student theoretically has a unique question, once again with the same formula. Now this is really simple. There's only 2 values. The formula is going to be quite easy here, but the more elements you include, obviously the more complex the question becomes. The harder it is to Google what the correct answer may be, bearing in mind the formulas do exist online. Harder it is for them to just check with a colleague or a peer. And what's really good here is if you can introduce double processing. It really helps with them stopping using Google to help. So this is basically a 2-step equation. So, for example, if they have to read the data from an image before they can apply the equation, or they have to change the units before they can use the calculation, they have to modify the data in some way, they have to take the beta constant away from the x before they multiply it by another factor, etc. If you make them double process, as well as adding the skill level to the student, it also makes it harder for them to actually do this. So this can actually be done on Blackboard tests. So I'm sure you're familiar with pools of questions, but if not, the email address I mentioned at the beginning can easily, we'll show you how to create pools of questions. The other option is to use the calculated formula question, which I've just got a quick screenshot of here. So here we can see a question. If the average Teletubby eats X jugs of tubby custard a day, how many will Y Teletubbies eat in Z weeks? So in this, you create a formula, which you can see in the bottom beneath. x times y, which you do first, then you times that by z. And you can actually stipulate in the question the values that x and y and z can be between. So z could be between 1 and 10, y could be between 5 and 18, and it will generate a random set question based on that. And of course, with the answer, you can ask for exact answers or derivations from that answer as well. So a quick way to create that kind of variation. Another good way to try and limit the amount of Googleness is to create something unique. So create something that's not on the internet, and then ask students to do something with it. So you could create a unique picture, a neat passage of text, perhaps a unique formula or figure, a neat sum or calculation. So I'm not saying draw a work of art here, but you could quite easily take an image. Let's just think of like a molecule, picture of a molecule, modify a structure on that molecule and ask them to identify where the error is. So, all errors are. So they need to know what the molecule is, first processing skill. Then they need to understand where the errors would be. You could use a hotspot technology to indicate on the image, or you can make it even more challenging by talking about what implications the error would have on the molecule's function. So yes, they may be able to find what's wrong with it, but then they've got to understand what the purpose of that is, and that could be identified by an MCQ. Here's a couple of examples. So first of all, original question, the type of thing you might see. Identify things labelled A to E using a drop-down list. So I'm sure you've seen questions like this. Got a picture of perhaps the human body with loads of labels on it, next to various organs, and using a drop-down list, you've got to work out which one is which. And of course, that's really easy to Google. Those kind of images exist freely. So here's an example, and of course, it's a nonsense question just to illustrate the point. So look at the image. What thing is not included? So we've got a picture here. This one happens to be colour blocks. And then we've got 4 statements listed as an MCQ question about ratios of coloured blocks. And here, the student would have to process the image, understand what its purpose is, and then make inferences in that in order to answer the question correctly. So there's a great cognitive challenge in there. The same kind of thing using a text question. So read the passage of text below, and which of these statements is most valid in the context of thing. So then we have a short piece of text. Once again, I've used a nonsense example. Quiz Bowl will consist of a double elimination tournament, which tournaments gain points by answering questions asked by a moderator. After successful answering a toss-up question, the team will be given a multi-part bonus question. And then there's 4 options there. So based on their processing of the answer, understanding the material, they need to come up with what is the most valid. They could all be valid answers, but what is the most valid answer to that particular question? I will say that these questions are not only harder for the students to answer, but they are harder to write, than a standard MCQ question. They are more challenging for us as educators to develop, but they do stretch the students appropriately and make them much harder to easily find the answers online. The next thing is to ask open-ended questions. Now, this is probably fairly obvious, and most people, amongst the reasons they choose to do an MCQ, is to avoid open-ended questions and to generate a self-marking test where, they don't have to do anything other than moderate the scores. But all of the questions I've talked about so far could be open-ended, and there's loads of ways that you can use open-ended questions in an MCQ. You don't have to use it for all of them, and if you do, you should certainly restrict in terms of number of lines or words, or give a guideline on the number of lines of words that the student should be producing in the answer to the question. But you could ask them to reinterpret some data, give some key findings from a set of data or a study or a statement. You could ask them to make conclusions from. You could ask them to justify their choices for an answer they're previously given. So perhaps which of these options do you think is appropriate, A, B, C, D or E? Maybe even give them a single mark if they do get the right one. And then ask them to justify their choice. So yes, the correct answer may be Googleable here in this particular example, but the justification for that choice probably isn't, or is harder to articulate. Now, Blackboard tests, particularly in the short answer question option, if you choose that one as the drop-down box, does allow you to add a rubric. That means you can create a very quick and easy rubric scoring sheet, which allows you to quickly mark these post-exam. The last two things are moving away from the Google questions themselves, just to think a little bit differently about how you create the questions, which can also help generate some of that rigor that you perhaps worried about. So traditionally, an MCQ question, if we think about it, when you're coming up with question ideas, often come from a particular lecture. Lecturer X, can you come up with 5 questions? And if we're completely honest with that, many of those MCQ questions come from a specific image or a slide or a source or a passage of text. Now, when you're doing that, when you're creating a question linked intrinsically to one thing, as well as increasing the chance that thing can be found on the internet, making it much easier for someone who knows the correct answer to share that with others. It's much better if we can draw or design questions that are at the module level, so drawing in multiple lectures, or even at the program level, drawing in learning from multiple modules. That way, all of the sources that the student has in their mind need to be synthesized and joined together and evaluated before they can come up with their correct answer. So that really adds to the cognitive challenge if you do that. So that's a real way of stretching the students and developing these more robust assessments. Now, the last thing relates to Bloom's taxonomy. So Bloom's taxonomy is the framework which many of our learning outcomes are ordered by. And the two lower order Bloom's taxonomies, so knowledge and understanding, are the ones which are actually much more tricky to assess by MCQs, because they are about remembering and recalling facts and figures. Now, in a closed book environment, people can't, look up the answers easily, but they could theoretically cram the day before the exam and retain nothing, which is actually a major criticism of them. So, but with online, they don't need to do that, but we need to make them more robust. So what about the higher order learning outcomes? So applying, analysing, evaluating, creating. So if you see the keywords I put on the slide here, these explain how these type of learning outcomes could work in MCQs. So just to give you a few examples. So an applying MCQ question could be something like, how would you solve thing using thing? How else could you plan thing in relation to thing? In light of the facts, what elements would you change in order to? Likewise, analysing could be, when considering what motive would be there to, using your ideas and opinions, justify how. In distinguishing between thing and thing, what assumptions can be made in relation to? Evaluating could be, what recommendations would you make about? Assess the value of thing with regards to thing. In relation to thing, how would you prioritise? And finally, creating could be, would you design thing in order to? Suppose you could thing, how would this be designed? Predict the outcome of thing by using thing. So, I know I've just fired off some examples there, but by creating more open questions using these particular kind of learning outcome words, often which could be combined with the use of images and figures and datas, really stretch and test the students. These often would be open textbook questions to answer. You probably need far fewer of these question types compared to the more traditional, short answer MCQs in order to assess the learning outcomes and give the students ample opportunity to express what they know to you. So that finishes this short presentation. So just a reminder that TEL do run talks on MCQ question design and designing the test themselves, which certainly you should consider if you haven't already before. Just in terms of further reading, my colleague and friend Dr. David Smith at Sheffield Hallam University has 2 excellent blogs on writing an ungoogleable exam question, which I have used as part of the construction of this talk, and I strongly advise that you take a look at them. Thank you very much.